Hello guys. So we will start shortly, and as this webinar later goes to YouTube videos, so for people who are watching it after the live stream, you might not be able to see the questions, so just ignore sometimes when I'm interacting with the questions. But apart from that, you can skip like the first 5 or 10 minutes where we normally discuss about the chats, and skip directly to the content where we work with Grasshopper. So meanwhile, hello everyone who are joining us live. Like always, seeing you and Guillermo. I'm sorry, I'm still unable to pronounce your name properly. Is the sound and the music correct? Or is it too loud? Today we are gonna see LunchBox, which is a paneling plugin. So I think it might be useful, especially in the case of architecture, but I think it can be helpful in any situation where you have to create repetitive panels. It can be like a facade of architecture or a building or a shopping mall, or it can be in a product like a handle of bicycle or some textures that you want to generate on a surface. With traditional methods, you can do it like simply in Fusion, Rhino, or tons of the softwares that are available. But Grasshopper is going to give you a lot more flexibility in that sense, so that you can generate really interesting textures on a surface. As I've seen, like in Render Weekly and a lot of places where people share renders, and some of them have really interesting patterns and textures. So I think this plugin is gonna be really helpful in that case. I'm gonna wait like 5 more minutes, I guess, so that more people can join in. But meanwhile, if you have questions or anything you would like to share, you can start writing in the comment section. How's cold in Canada? Seeing you. You guys are not interacting today so much. Hello, Navan. No, it's not so bad. Okay, perfect. Yeah, actually here in Madrid it's sunny and you can literally go outside in short sleeves and you won't even notice. Well, Canada is a different case, but just note for the first beat again and last. That was a little slippery. I think what I can do actually is maybe pop out the chat box and put it in the live stream so that more people can see what's happening. Oops. Yeah, so that they can get the context about what we are talking. So we have 4 people right now. We're gonna wait 5 more minutes till it's 5:10, where a lot of people they join and then start with the webinar. So are you guys working? Are you guys doing internship? Or like, if you would like to discuss about that. And new people who are joining in, please write at least a hello or something so that I can make sure. Working in school. Okay, seeing you just applied for one place this week. Are you did you graduate recently, or is it about like you have done internships and now you're working, looking for work? You're working full-time and doing graduate part-time. Okay. And I think you wrote me in Instagram. I think you're working in an architect firm or something related, probably. Was working, yeah. Working on your portfolio. Yeah, I remember. Like, so the first time I was looking for work, I had to dedicate around 4 to 5 months, like just make my portfolio and make my website and document everything properly. Like, well, it was documented but put it in an organized way. So it takes a lot of time, but good luck, and I hope you get what you're looking for. Yeah, that's obviously like the more you work on your portfolio. However, it's really important that when you are doing the projects, you document them properly. That makes the portfolio process a lot easier. So good luck to all of you with your future endeavors. I hope like implementing what we learn here also boosts your portfolio and capacity to do more. Yeah, that's also true. Like if you over document, then you have always to you have a limited space to show your work, and then you have to make a choice what makes sense and what doesn't. Yeah, because it's really hard to generate content post once you have done the project. Okay. The curation is the hard part of me. Yeah, I think today there are gonna be really few people because generally by this time we are around 25 to 30, but somehow I think everyone got the email, or if the link is working properly, but right now we are just looks like we are just 6, but no problem, like they can come back and watch the live webinar. Yeah, it's a slow day. I think a lot of people don't know about LunchBox. Maybe that's why Kangaroo was like so far the most viewed. There were around 36, 37 live viewers. I mean, it's already 5:05. If you want, we can start. We can start the webinar, no problem. And yeah, today it's gonna be shorter because the LunchBox plugin is really simple, but at the same time complex. So there are bits and pieces that we are gonna see which are gonna be really like most used, and there are parts where we won't be looking, like we are not gonna touch in this webinar because it's totally different kind of components inside the same plugin. So the Proving Ground company, they are doing a lot of stuff, and they put different things in LunchBox. So they have introduced the machine learning part in LunchBox somehow, and I tried to tweak with it a couple of months ago, but I haven't found proper use for it yet. I mean, sure there are, but in what I do and what I like to do, so I'm still figuring out. But at the same time, there are other components which are really easy, and they're just gonna make the whole pattern generation process so much easier. And when you combine it with Weaverbird, instead of modeling in NURBS, it's gonna be even faster, your workflow. So basically, like, you can generate really complex patterns in 5 to 6 components. So yeah, we can start by maps. For our new viewers, I'm an industrial designer, but at the same time I really like computation part of it, and like to research how I can implement algorithms inside industrial design field. And we have been familiarizing with everyone here in the group, so maybe you can watch in the chat window and see like the questions and introductions. This is really important. We always have to be patient and keep on practicing and be persistent in order to I feel like a Japanese dude, but to be a master in Grasshopper, but this is really important, not for anything else, but once you start using it as a daily tool, you start to think directly in a Grasshopper way, I could say. So it gets a lot easier if you are using it even for like simple projects. So yeah, make it a tool that you're gonna use maybe once every 3 days or something like that, and it's gonna be fresh in your mind. So we are gonna have a look at LunchBox. Yeah, okay, so maybe people are commenting. Seems like we'll always go back to the Weaverbird subdivision part. Yes, exactly. I mean, we go back towards it because we don't need to go back towards it. We can start directly by modeling in NURBS to have more control. But with so far the easiest to do is the subdivision, because if you are starting to work with NURBS, yeah, it takes a lot more computation, and if it's a small pattern and small stuff, then you can do it. But once you are getting into maybe 10,000 faces or something like that, then your computation time increases drastically. So the subdivision part is really fast in that case. Okay, so we're gonna look at LunchBox plugin. If you guys want, you can follow along the exercises, or you can just watch. So let's fire up the Grasshopper meanwhile, if you haven't yet. I'm gonna say to people who are asking, so okay, everyone's ready with their Rhino and Grasshopper environment open? Perfect. So we are gonna design a wall with panels. Yeah. Yeah, I mean, we can do it the other way. Hello Celine, you're a bit late. The webinar is supposed to start at 5, but no problem. How have you been? I was thought the NURBS were superior to mesh in basically every way. No, it's a trade-off. Like, NURBS are mathematical formulas to represent a geometry, and meshes are actually 3D points in space. So sometimes it might be easier to just write a mathematical formula which takes a lot less resource and space than the actual points in 3D space. But there is like certain threshold, no? Because once you start to design complex mathematical geometries, it's gonna take a lot longer computationally than just pointing 3D points on a 3D space. So that's what I was saying. Like, you know, you can work in NURBS, but after a certain point, you have to go back to mesh, especially if you're working with organic shapes, if you're working with repetitive structures and stuff like that. And you can watch this pattern in almost every 3D modeling software. Like, you can go back to on the online resources, you can see the trees and like plants, they're 99% time in mesh. And in architecture too, like you use 3ds Max, and they all use mesh. So it's a interesting simian relationship between mesh and NURBS. But in industrial design, we do use a lot more NURBS, like SolidWorks, Rhino, and because the geometries are a lot smaller, and like it doesn't need to contain so much geometrical data in it. If you compare it to, I don't know, like organic shape, or if you're comparing it to trees and stuff like that. Okay, makes sense. I was always thought ID were needed to hands off final NURBS. Yes, that's true. In industrial design, we need to hands, depending upon the manufacturer, but they generally ask you IGES or like SolidWorks basically. So yeah, it's gonna be at the end made with NURBS. And you might say, like, why don't you start directly with NURBS? The thing is, the same time, the iteration process takes a lot of time and resource. So I would iterate like a lot of variations using mesh. And once we know like this is gonna work, because you can 3D print a mesh, and you can basically have so much resolution in the mesh that you cannot even make the difference between a NURBS and a mesh if you 3D print it, or even if you send it for injection molding. Like, you know, you can even have the resolution for the surface quality. No, it's fine. This is there is no topic at all. We are just trying to see where we can get with computation and design. So everything is perfect. I really appreciate you guys asking questions and doubts, because I mean, plugins as such, you can watch YouTube tutorials and learn, and maybe watch some PDF. So yeah, keep them coming, the questions. And also for it's really interesting, even people who are watching it offline later. Okay, so getting back to Rhino environment. So let's make a curve. Just a second. Okay. So I'm gonna import the curve.
I created the matrix.
I'm gonna extrude. In the Z direction. So in a typical workflow, if we want to create panels, we have a lot of like different options. So one of it is isotrim. So what it basically does is it cuts the surface from a domain point to a domain point. So you can create it by divide domain in the component table. Hello Aman Sashan. Yeah, you are really late, but it's fine. Also happy, high resolution, blah blah. Do you have to turn on the component labels? Sorry, yeah, bifocals. Perfect. Thanks for pointing it out. So we start with divide domain. So what it does is it takes the surface as input, and it creates a UNV domain from that surface. So in this case, you can see it's from 0 to 100 from U, and from V it's 0 to 261. Basically means the height is from 0 to 100, and if we change the height here, it's gonna change it here also from 0 to 79 and 0 to 261. Sorry. And we can say oops. I'm a bit sick, so pardon. So you can divide the cells as many times as you want, defining the UNV count here. Perfect. So like now you have created the panels, and you can then later maybe do more operations, like evaluate surface, MD slider. So it's reading all the surface as one, so we can maybe graft it. And reparameterize. So we are gonna set it to 0.5 and 0.5. Oops. Perfect. Okay. Yeah, I have turned down the music a bit. Maybe better now. We can draw a line from this point normal to the surface. So we use SDL. So the starting point is that. The frame is the direction. As you can see, it has already created the line, and the length is how much the length we want. And if you want it the other way, you can do a negative. And we can continue working on. So for example, we can maybe create a loft, a point loft, sorry. You can go freeform, you can select the extrude point. How are you guys doing so far? Doubts? I'm gonna leave it a bit like this. So what we have done is we have a curve that we drew in Rhino, then we imported the curve and extruded it. So we have a curve, we extrude the curve, we divide the domain and create isotrim. to create surface, and then with the surface we evaluate the center point of the surface using the MD slider and evaluate surface component. Your evaluate good, but my evaluate surface component displays the frames. First you need to graft. I think you don't need to graft, you just need to reparameterize. So you reparameterize the surface so that it becomes 0 and 1 here. So 0.5 and 0.5 becomes the center point. So that's why you get the center point. As you can move the center point, but 0.0 is the center point. And from this center point we are drawing a line. The start is the center point, the direction is the frame, and the length is the length that we want to give it through a numerical value. Okay, so the graph, it's not necessary. I thought it was not interpreting the surface individually in a different list. So so reparameterize, what it does is, imagine you have a curve. So let's import the curve. You don't need to do this, I'm just going to explain it to you. And we use evaluate curve. So what we are saying is, for example, length. So the length of this curve is around 171 units. So if we say like maybe 2.5, the parameter. So as you can see, 0 is here, and then as you keep on increasing the number, it travels along the line. But when you reparameterize a surface or a curve, when you reparameterize this, what it does is it changes the starting point as 0 and the end point as 1. So, and that's why this is giving us an error, because it has to be something between 0 and 1. So as you can see, 0 is there, and as I increase, 1 is max and 0.5 is gonna be the center point. So reparameterize, it does is like remap the whole length between 1 and 0, 0 and 1. So this is what we are doing. Here what we are doing is we have a lot of surfaces. So let's say list item, we are selecting the surface number 0, which is this surface from all of this surface, and we want to evaluate the surface, and we connect an MD slider towards. And let's maybe remove the reparameterize from here so we can see what's happening. So as you can see, this surface has a length of U and V. V and U. So if we change the value in the MD slider to evaluate the surface, 0 is the starting point of this rectangle, but 1 is not the end point because it's a lot longer than 1 from in the V and U direction. So that's why when we reparameterize a value, what we do is we say that the U and V values are 0 and 1, 0 and 1. And now when you move the MD slider, it travels the whole surface. It covers the whole surface. And if you want the center point, you can do 0.5 and 0.5. Did you get it? Yeah, reparameterize is super useful. because, or else what you need to do is you go to maths, you have to remap numbers, and it's a lot more complicated. Like you take the value, you say the bound, and you say 0 to 1, and then you can remap it. And the easiest way is right click and reparameterize. So yeah, we use reparameterize a lot in that sense. Anyway, so back to the Grasshopper definition. We reparameterize the surface once again, evaluate the center points, and draw a SDL line. So let's maybe create a loft between the edges of this of one isotrim of one surface to the top point. So how we can do that? So for example, let's say list item. So we are talking about maybe the first surface and the first point and the first line. So this is just for demonstration. So I have selected only one part before applying it to all of them, so that it's easy to visualize. So we have the surface, we have the point, starting point, and we have the line. So what we want to do is we want to, from this line, draw a surface that goes from here to the top of the point, something like that. Okay, so to do that, first we have to change this surface into a curve. The easiest way to do it is just connect a curve container. So Grasshopper is really intelligent in this case. So I mean, they have programmed it in such a way that you have a surface, but when you connect a curve container, it automatically converts into curve. Then we have the point, and then we have the line. And to get the end point, because in this we need the base, which is the curve, and the end point is the top of this line, we have to connect end points, which gives the two end points of the curve. So I think the end point is going to be this. So let's see. Yeah, so it has created the surface. So we can apply it to all of them by first turning off the extrude so that it doesn't crash. I'm gonna save it just in case. Loft. So we have this curve and we get the endpoints, and this is the iso surface. So we have all the curves and we have all the points, and we want to extrude. So let's turn it on. So yep, it was able to do it without any problem. And we have generated a surface with spikes. You can control the length. So yeah, as you can see, we have to go through like this step, and not just that. For example, right now it's kind of rectangle, but what if we want to make it using a hexagon, or change the shape, or a rhombus, or a triangle? In that case, it becomes a lot more complicated to do it with the native limited options that you have available here. So that's why the comes handy the LunchBox plugin. So let's make a copy and turn off the previous model, and let's delete almost everything here, like that. Make the surface visible. So far so good. Is the sound better now? Can you guys please comment if everything is ready to go? All right. Okay, so in this case, now let's get back to the LunchBox panel. Have you guys installed LunchBox, right? Also, I would like to write what kind of softwares that you guys use for industrial design, for example, SolidWorks, Solid Edge, or Creo, PTC Creo, or Katia, because we are going to see some examples how to make it work with Grasshopper, with SolidWorks or Solid Edge or Katia. Perfect. So as I can see, all you have the LunchBox plugin. So in this case, it's basically you go to the panels tab and you have all the possible panels that a lot of us will need and will be sufficient. So for example, let's start with the diamond panels. So you connect the surface here and you get the panels. Like, you don't need to divide it, you don't need to create the lines, and voila, you have the diamond panels. I would change my surface type. I would create maybe a circle and give it a bit more height. Something like that. And you get the panels. We can also use the hexagon panels. So you have the points. We can use the quad panels. The same like before, like how we did it here, but this is square. We can do maybe random quad panels. We can do triangle panels. So just keep on trying different combinations and how they are generating the results. So for example, going back to this, let's create a surface. And rebuild the surface so that we have more control points. And I'm gonna modify a bit. All right. So let's import the surface. And let's import the diamond panels. Yeah, the the rebuild is to add more control points so that you can later modify the curvature of the surface. Okay, sorry, once again. So I created a surface. So how do you create a surface? You can either go to surface, corner to corner, or you can go here and create a surface like this. So you create a surface, more or less. But as you can see, we cannot change the curvature. We can just select the endpoint. So we don't need this. We want to create like a double curvature surface. So to do that, what we need to do is rebuild the surface, because right now the surface is 1 or 2 degrees, so we want to convert it into 3 degrees. So you select the surface and you turn on the rebuild command, and here they're gonna ask how many points do you need on the U and how many points in the V direction, and the degree. So it was a 1 degree surface, and now we want to convert it into 3 degree surface. So we say we want 7 points in the U and 7 points in the V, and we say okay. So now when you turn on the control points, you can see that there are a lot more control points, and when you move them, it generates like a smooth surface. Make sense? Oops. And once you have made the surface, you create a surface container and import the surface. Perfect. Are you able to follow along, Navan? Yeah, because if you choose like this is degree 1, so when you have 1 degree, you don't it's not interpolated. When you rebuild and you have 2 degree of curvature, it's almost like degree 3, but it's a lot more stiffer. And when you say rebuild and you do degree 3, and now it's like a and it doesn't stop at 3. You can even go like degree 6 or something like that. So it's like just a mathematical formula how to how the points how the surface is interpolated. Okay, so we import the surface. Yeah, okay. Linear, quadratic, cubic. So we import the surface and drag down the diamond panel and hide this one. And you can control how many U and V points you would need. So maybe even more. Something like that. And we can copy from here, or we can do it here, don't worry. Oof, I'm sorry for my bad cough and cold. I hope I don't have any virus. And one thing you have to notice here is that this component generates two kind of list. So if you look at this one, the top one, so it will separate all the proper diamond panels, and in another list it will leave you with the triangle panels which it generates at the edge. So it's really interesting because both of this surface have different topology, so you can create two lists and manipulate the data, and then you join them at the end. So for example, let's just work with the diamond panels for now. Hide this one. And let's bring the evaluate surface and the MD slider. So as you can see, it's like there, but how we can make it at the center? So we have to reparameterize the surface. So now it's in the center. We do the same as DL. The starting point is going to be the center point. The direction is the frame, and the length is the length of the line that we want. So in this case, maybe 15 or something in my case. Okay. And we can do the loft point to a point, surface, freeform, extrude to a point. So the base is gonna be the surface. Oh no, sorry, the curve. We create a curve container so we can convert this surface into a curve. So these are individual diamond panels. So that's our base, and the point is the end point of this end point is the extruded point. So before doing that, I will save my Grasshopper definition. You can internalize a value, internalize the data. So internalizing data means Grasshopper will store also what you did in Rhino. For example, we made the surface and then we imported the surface here. So if I move it, everything comes with it. But you can also internalize the data, so it will store the surface information within the component, and even if you move it, you delete it, it doesn't matter, it's gonna be here. Okay, so I sometimes use it because then I don't need to worry about saving my Grasshopper Rhino file. I just need to have my Grasshopper file, and that's it. So yeah, the internalized data is really useful. You're gonna use it a lot often. Okay, perfect. So we are gonna create an extrusion between the curve and the endpoint. So seems to work properly. Yes, it works properly. I'm gonna hide everything else. So yeah, you can see you can create like a lot of patterns in that sense. We can also, for example, instead of creating like a pointy one, we can even make it like a flatter one. But for example, let's do the subdivision, my favorite part. So we convert it into simple mesh. So these are individual meshes, and we do cat-mul Clark. So as you can see, we have created the individual surface, but we want it to be a continuous surface, so we have to join the B-rep. So in the extrusion component, you have to join all the separate pointy extrusions into one B-rep, and we convert this B-rep into simple mesh and then do the cat-mul Clark. So there you have the geometry. To visualize it properly, we connect a custom preview component. Swatch. And you can control the depth of the texture. When you want to ask for help, and this is the first thing when you ask for help on the GH forum, they ask you to do that. Yeah, because a lot of people share their Grasshopper files, and the people who want to help won't be able to help, because when they open their Grasshopper files, they don't have the geometry. So either you have to send the Rhino as well as the Grasshopper file, or you can internalize the value in Grasshopper and just send one file, which is a lot better. Yeah, exactly. So for example, right now this is a simple mesh, like you cannot 3D print it, but if you thicken it by some distance, and then you can 3D print it. So we have the simple mesh that we have. So this is a bug in Rhino 6, or at least in my case, that when you have a geometry preview in the rendered viewport, even if you hide it, it's still gonna be visible. So I need to turn it off so that it doesn't render. Anyway, so we have, going back again, the surface. From the surface we draw the diamond panels, and we separate the tri-panels and just select the diamond panels. We evaluate the surface using MD slider and reparametrizing the surface. On the other hand, we convert the surface into a curve just by connecting to a curve container, and we create a line starting from the center point going towards the normal of the surface by connecting frame into direction and giving it a length. Then we select the starting and end point of the line that we draw and use the end point as where we want to extrude. And once we have extruded, we make it a single B-rep. If you want to know more about how data is like transferred between the wire, so for example, here you can see there are like two lines. Here it is just only one line, and let's say if we do something else, so let's say if I connect a surface tab and then maybe create a panel or something. So for now this has two lines, this has one line, and if we graft it here, it's gonna have like the dashed line. So all of these three lines means different things when you are working in Grasshopper. Like just going it really fast, single line means it's just importing one value. So as you can see, there's only one B-rep. Double line means there are a lot of values, but in the same list there is only one list, and there are a lot of value, more than two or more values. And when you have graphed, it means there are more than one list. So it's a really fast way to understand what how the data is being flown in your Grasshopper script. So and how you can turn it on. You can turn it on here, draw fancy wires, because if you have turned it off, you're not gonna see what's happening. So go to display and draw fancy wires. There you can see it properly. Anyway, so we did one BREP mesh, then convert it into simple mesh. And there is also a difference between simple mesh and BREP to mesh. So I think you can see a little bit, but as you can see here, when you connect the mesh to BREP to mesh, sorry, this component is not the best way to create the subdivision later on, because it creates more faces than is necessary. But if you compare it to this one, you can see it only creates like a simple planar surface, mesh face. This one has like a lot of lines in between, and this one is simpler. So the simpler it is, the better it's gonna be later to do the offset and do the subdivision. Anyway, so we have simple mesh, we give it a thickness. So if you want to give the thickness towards inside, you connected it to a negative value, and then we do the Cadmo-Clark. So this thing now you can actually 3D print. Okay, so even if we bake it, so there you have the texture that you want to generate. So let's say we have maybe a device that we are gonna make, for example, like a battery or a hard disk cover, and have solid fillet edge. So we have like a battery pack, and let's maybe explode this one and connect this surface over here. So we have created the packaging. So as you can see, it's not the best way, like it's not looking how we want it to. So we have to make sure what's happening. So for example, the surface that we imported, is a lot bigger than how it's generating the surface. So maybe what we can do is later clean the list by removing the end panels. Or I think we can maybe do even a better, faster example. Let's say if we have a cylinder, it might not work properly in the cylinder case. Internalize data. Okay. So as you can see, it's not working properly on the back side because of how the geometry, because it is, the rest is here, like here. Maybe we can do it like this. Wait, flatten it. No, flatten it, and then connect this one too. So it's a lot better like that, but still it's not one surface, like one continuous geometry. But as I said to you, like this is really handy when you are like iterating your design, like, you know. So for example, this can be a bicycle cover or something, like a handle, bicycle handle or something like that. Yeah, I hope who are not here are missing out. So I'm trying to figure out a different use of this plugin for, I mean, for architecture there are infinite uses, but for industrial design we can do patterns and stuff like that with this, because wait, yeah, it was here. So if we use this surface, and this is not a surface, and there is the surface. So yeah, I mean, you can once you know how it works, you can start playing and experimenting with it. No, because you cannot join the surface before evaluating it, because it's gonna sorry, it's gonna interpret. Okay, so yeah, because it's a B-rep, so you cannot, it's not gonna work, the component's gonna fail. Anyway, so let's move on to different kind of patterns. For example, let's go and work with the hexagon panel. The same, we're gonna connect it to the surface, and let's try the surface that comes with the LunchBox plugin. So for example, let's open this one, Kevin surface, Klein surface, sorry. So you have a surface, and let's connect it to the quad panels. And we keep on increasing the number of U and V parameters. Something like that. Yeah, something like that. And we can create maybe like a frame or from these components. So as you can see, it generates as well as the frame or the internal panel. So if you connect the surface, so it is generating just the frame or the inside panel. And like that's a good thing about this plugin. So it gives you into two separate lists, so that you can later manipulate them on their own way and then join them. So for example, what we can do is maybe thicken it. So it's not going to work because it's surface. Then we convert it into simple mesh. It's giving me some error. I'm just trying a few things. Okay, so it's not generating the simple mesh as I was expecting it to. However, it is doing it here, so let's maybe try using the generic component for converting BREP into mesh. However, as I told you, like as you can see, this looks a lot messier than using the simple mesh face. I'm going to cut mode Clark. How are you guys doing it? Are you guys able to follow along? So it's taking a lot of computation power, but yeah, it's lagging. Maybe because I'm doing stream and this is a really resource intensive plugin, unlike the operation. And I think it has a lot to do with the mesh to BREP because it's generating a lot more mesh faces than what is needed. So it's better not to use this. Maybe what we can do is maybe use curve. Let's see. No. So it is generating the exterior curve, and I think if we can connect it to the panel, it's generating the interior one. And we can maybe create a loft. But before connecting, make sure I messed up. Oh no. Yeah, I mean, that's why before, so this one, it's just basically here before connecting to Loft. Wait, I'll explain. My editor is asking if you can see the whole script. So we start with a clean surface that you can find in the LunchBox plugin under the math clean surface. Then we have connected it to a quad panel, which is here. Sorry. And we have connected a panel frame, which you can find here. And to convert this surface into curve, I have connected a curve container. And here in the panel frame, the inside panel, I have connected the curve container to get the inside panel. So before doing the loft operation, make sure to graft both. So as you can see, now I think we can connect the simple mesh. Sorry, before the join BREP. Flatten it so that it is only one BREP. Yes, it's only one BREP. The hexagon panel, we are gonna see it because it doesn't generate a surface, it generates curve. But I'm gonna explain it to you, don't worry. So now we have a BREP, and it's a lot better now because they are made out of a straight planar surface. So once we connect the simple mesh, It should work now. Yes, now it works. So we have the simple mesh, we do the thicken. So it's doing it inside, but we can make it outside by connecting it to negative. And now do the cut mul Clark. So, sorry, as you can see, the whole process of mesh, like as you were asking before also, as you can see, this is 3% of the resource. If you are not able to see the percentage below the components, you have to go to display and canvas widgets and turn on the profiler. Okay, display canvas widget, turn on the profiler. So what it does is it calculates all of your Grasshopper definition and sees which is a process that's taking the most time. So as you can see, the most time that's taking is this, like whenever anything has to do with like the brep, like the NURBS, so it's taking a lot longer time. And once you get into mesh, like doing this, like thickening it, is a lot easier here than maybe doing an offset of surface. So I'm gonna save it because I think it might even crash. So it's giving me maybe here. There are individual breps on the surface. Wait, so maybe if I connect this, yeah. So as I was saying, like it takes a lot longer when you're working with brep than when you're working with mesh. It might happen the other way in some cases, but generally that's the trend. So we can custom review. We can even control the scaling factor. Any questions? Okay, so sorry. So what we're gonna see is finally one with the Hexagon panel, and then move to the workflow. So let's draw a surface once again. Rebuild it. And import the surface. I'm gonna hide the surfaces. Perfect. So as you can see, right now it's not giving us the surface, it's just giving us curves. Okay, so let's say if we wanted to draw something similar that we did here, like pointing in the normal of each center point of the hexagon like a line, and then extruding the hexagon over there. So how we can do that? So let's say yeah, and sometimes when I'm working, I generally you start with low values, and then once you know it's working, then you slowly increase the value so that you can iterate faster. So first of all, to create a line perpendicular to the surface, we need to evaluate this surface, which is this one, at the point. So how we can do that? First, what we can do is we can pull the point from the hexagon center on the surface, like you can pull it. So it's gonna be a really good approximation of where the center point is for the surface. So let's say pull point to a variety of geometry. So maybe the point is that the centers and the geometry is the surface. So it's basically there, but in some places it's a bit far. For example, here, as you can see, this point is maybe it's in the center, could be, but the problem is here it also gives us the point, but it doesn't give us the normal of the surface. So what we have to do is evaluate surface, and the surface is the surface, and as we saw, you can either give it an MD slider or you can directly give it the point. Oh no, closest point, wait, I'm doing something wrong. Maybe the better would be pull BREP closest point. Wait, yeah, could be this. So the point is the center, the BREP is the surface, and it gives me the normal. So let's say if I want to draw a line starting as the point, yeah, so this is better. Sorry, I apologize. So a better way to do it will be, so we have the surface and we have the hexagon panels, and we do BREP closest point, which means it's gonna evaluate a BREP and then pull it towards the BREP. The other components also, they did the same, but the difference in this component is it gives us the normal value. We need the normal value to draw the line. So for now it's just pointing in the Z direction. So if you connect the normal in the direction, it's gonna adapt towards the normal of the surface, and you can control the length later. Are you guys able to follow along so far? So what we can do is scale the cells. So we are using the hexagon cells and you want to scale it. So it's scaling like that because it's only doing it from 0, 0, 0, but we want from the center. So each hexagon cell is like that. We can control the factor between 0 and 1. So 0 is like that, 1 is full length. And we want to move this geometry along the line. Okay. And so we have the cells, which are these, and then we have the geometry, the scaled and moved geometry, and we're going to create loft between these. Before continuing, don't forget to graft because what we want to do is to take this curve and then this curve and perform the loft, and not take all the curves and do one loft. So we have to create a graft. So it's gonna take the first item from this list, the first item from this list, and then the first item from this list, and perform the loft. Okay, so we have this geometry. We have to join the B-wrap. Don't forget to flatten or else it's not gonna join. You have to do simple mesh. And then thicken. Maybe it's better if we do it outside, so I'm gonna do a negative. And then you do the cut move clock. So we can control basically the whole aspect of it. Maybe change the factor a bit more. Something along that line. They're still intersecting, so maybe the length should be less. Doubts? Any doubts? Anything to add? You guys are also really bored today. Okay, so we are gonna leave for now this part. So I'm gonna show you something different, but it's an advantage that the plugin has. So for example, when you go to the workflow panel, you can see a lot of components that has to do with Microsoft Excel. So for example, you can read or write a Microsoft Excel file. And you might say, okay, it could be handy if you want to export, I don't know, like construction data or some beam information from Grasshopper and generate a like a like information booklet or something like that, and you can print it. But Microsoft Excel doesn't has to be Excel, but any CSV value can be imported in a lot of different softwares, and it, and like as well in SolidWorks, Solid Edge, and PTC Creo. I think you can even import it in Fusion. So the good thing is a lot of these softwares permit you to import Microsoft Excel or CSV comma separated value inside their work environment. So what we can do is we have on one side Grasshopper, and then we have the software that we want to import the value, and we use Microsoft Excel as bridging between these two softwares. So we can see maybe a demonstration. I hope it works, because sometimes it's a bit laggy, or it's a bit buggy. So let's import the, you might not have Excel, so don't worry, or you might not have the other part of the software, like I have SolidWorks, Solid Edge. So you can just watch it, and maybe like half part you can follow along, and the other half, depending upon your software, you have to figure it out. But it's basically the same for almost all the softwares. So for example, this component, in the workflow, you have an option called launch application. So you can even use Grasshopper. So for example, I will connect a button, and I will connect a path, a file path. So I will define one existing file path from desktop. There's a Excel file that I have created, so I'm going to connect these two. So when you push the button, it will automatically launch the application. So I don't know, like you can create like complex systems where you can open certain applications, and then these applications can start recording the data. So it comes handy. And here, as I told you, it's a bit buggy, so I was like the part of scrolling part was hanged for a bit. So here, for example, we say we want a value of 50 in the column heading, in the first column, and the column heading of hello world. So okay, yeah. Sometimes it might not work. Let's see if it's working right now. Yeah, so for example, as you can see, as I'm changing the value from 27 to something, and I'm connecting this to column number 1 as well as the right toggle. The right toggle means whenever there is a change in the value in the entrance of this this point, it's gonna make the component work. So when I change a value, it's gonna execute this component and do the necessary changes. So for example, we can control this value and export the value data to column number 1. So at the same time, I'm gonna open my Solid Edge, which is basically same as SolidWorks, but it's from Siemens. Yeah, and I'm gonna create maybe a new file. A part. And I'm gonna just create a basic box, something like that. So as I change the value to 50, it adapts. Maybe 160, something like that. And this this program has the Excel part located in the tools in the variable panel. So here, when you change a value from 50 to 60, it adapts accordingly. So what we can do is we can link this table to Excel and then control it from Grasshopper. How we can do that? So in this case, I have to log the dimension. I have to go to Excel, right click, copy, and paste link. So as you can see, the value 47 automatically was imported, and I can close this for now. I'm gonna create it like this. So whenever I'm changing the value, I can control my 3D software, in this case Solid Edge, from Grasshopper. And obviously this is a really simple demonstration, but you can create really complex connections between, and even run like genetic algorithms or Galapagos or other kind of stuff, and then directly model in your preferred software. It's like making it parametric. You have to do a bit of work, but once you get it ready, you can then later do a lot of interesting stuff over here. Yeah, exactly. So you go from Grasshopper you go to Excel, and then Excel to the preferred CAD software. Perfect. So any doubts in this case? How did you connect the Excel file? Could you show that again? How did I connect the Excel file from inside Grasshopper, or from the other 3D software? So basically, yeah, so in the LunchBox plugin, you go to workflow and you can find these two components that read and write Excel data. So the top one, you don't need to open the Excel file. However, it's not dynamic, so it's gonna write the new value and save it. So it takes a lot longer, basically. But if you have the file open, in this case I have it open, you can use the workflow and go to write legacy, Excel write legacy, and you bring down this component. So what it basically does is it analyzes if there is one open Excel file. Make sure you only have one Excel file open. I'm going to turn that off. To make the component work, it's going to need the input parameter column heading failed to collect data. So let's provide a column heading. So we can say solid edge or some value, and hopefully as you can see, it's not doing any change because we have to toggle to make it right in that Excel file. So let's maybe connect a button so we can do it manually. Oh, okay. So as you can see, so it's writing, it's a bit buggy as I was telling you. Maybe it's not able to write the column heading once again, but let me maybe delete it and try it. Yeah, so it's not writing in the first place, but in the column number 1 you can write any value, and when you toggle, when you give any value in the right toggle, it's gonna make the necessary changes. Right. It's a bit hard to manage so many tabs at once, so maybe this. Maybe row start. It's a bit laggy, as I was telling you, like sometimes it might not work properly. Sorry, my mistake. So to rewrite a value, what we need to do is clear the sheet, and we haven't done that. So let's create a boolean toggle, and yeah, so now it's, so it erases everything and just writes the value. However, it's not writing in the column 2, 3, 4, 5. It's a bit buggy, but you can make it work. Do you know if it can handle large data? Yes, I don't think there is any problem from so for example, let's say and maybe do a multiple data. So it's writing all the datas here, and if I go here and turn on the variable, and so the first one is 53, so maybe second one is this one, copy paste link. Third one is this one, which is 54. So when we change the values, so I mean, yeah, you can make it work with even more values depending upon the software that you're gonna using. I don't know what software do you use, but for example, the Excel thing, you can even do it with Revit and 3ds Max. So I think you can make it work. The problem is, how do you interpret it, the data on your software, because you cannot export curve, you cannot export surface, you cannot export mesh. What you export is just numeric values, and how you can create the relations in the on your other software. For example, in the case of Solid, we are basically controlling the dimensions using just one numeric value. So I cannot import here a point, but if I'm able to create a logic structure where I give 3 values, and the 3 values corresponds to X, Y, and Z, maybe you can make it work. So depending upon the software that you're going to use, it might be easier or hard and worth the time or not, because the best way will be to model everything in Grasshopper and Rhino, export it in the native file format that your software accepts, and then continue later on from there. So you have to evaluate if it makes sense for doing the changes or not. So any doubts? I'm sorry this webinar was a bit more not boring but slow. But I hope the LunchBox plugin will be helpful in designing new things and generating pattern. Yeah, you have to give it a bit more time. So anyway, let's see, we have seen this and this. Yeah, you can connect Excel to SolidWorks. So the book of the day is Evolutionary Design by Computers. So I have recommended already Peter J. Bentley's books earlier, and this is also a really interesting book. As it said, Darwin would love this book, even by Richard Dawkins. So this book is really interesting if you can get hands-on. I don't think it's gonna be cheaper and easier to buy it in Amazon, but there are second-hand book companies. For example, in Spain we have Iberlibros, and you can buy a lot of second-hand books here. So for example, the one which I was telling you, Peter J. Bentley. So he has written a lot of books, and let me see if I can find the one which I'm talking about. Computers. Because as these are second-hand books, you might not find all of the time what you are looking for. No, I think it might not be available, or just a second. I might copy the ISBN number. Yeah, so there you go. So for example, here if you buy it in Amazon, you can buy it either from 56 euros or 131 euros for new ones. And here you can buy it for 24 bucks plus 5 euros. So you can it's really cheaper if you can buy it here and buy from Iberlibros. I think there must be some companies for your proper country, but if you're in Europe, you can use this website, and it's really nice, because a lot of books also come from the US. So maybe, for example, this one, although it's really expensive, it's 54 and 6. So yeah, make sure to search for books here, because they have really nice price. And this book is really it's really old, but the concepts are still interesting to this date, and how you can use computers to design in an evolutionary method, like iterate, and he showed in the book some examples of how he was using it back in the days. Like he made a coffee table using generative and evolutionary algorithms. So this might be interesting to have it in your shelf. As you can see, I think no one's new. I think all of you have already filled the form, but people who are watching it offline, you can please visit the link that I'm gonna leave in the description of the video to provide a feedback. I'm gonna even paste it in the live chat. And please do fill it, because I have to make sure that we are talking about relevant plugins. You can find about some more works in the web page that I've been lately doing, and in the Grasshopper tabs, make sure to look for the next webinar date and time. You can get some files to play along in the Gumroad page. And yeah, that's it for today. I hope this webinar has been helpful for you to learn more concepts of computational design. And this tool, this plugin was really good for like pattern generation and facade generation. So would be really interesting if you guys are making you're using this plugin. I would really like to share it in my profile, so just tag me and I will repost. And that's it for today. I hope you have a really nice weekend. If you have more questions, can you please write it down, and so that we can end for today. Yeah, we are just 3 viewers. This has been really weird for today. Perfect. So see you guys in the next webinar. Bye bye.